a little bit more complicated indefinite integral. Here they asked us to calculate the indefinite integral of 3x over 6x squared minus 15. So to do this, we're going to use the substitution method. And the first step in the substitution method is to figure out what we should choose our new variable u to be equal to. There's some choices you can make here. You might choose u to be 3x. You might choose u to be 6x squared minus 15. Or you might choose u to be the whole fraction itself, the whole integrand. The rules when deciding, or the guidelines for deciding what you should be substituting for, first you want to make sure that when you substitute u in, it actually makes your integrand simpler. And the second thing that you kind of want to look out for is whatever you choose u to be, take its derivative and see if that derivative occurs somewhere else in your integrand, or a constant of your derivative occurs a constant multiple of your derivative occurs somewhere in your integrand. So in this case, what I'm going to actually choose u to be is 6x squared minus 15. The reason I think that might be a good idea is if I have a u in the bottom here instead of this big denominator, that makes my life easier. But also if I look at the derivative of this choice, it's 12x. 12x is just 4 times 3x, so it's a constant times something that actually already exists in my integrand. So this is actually a good hint that this version of u might be a good idea. So let's give it a try. So we have the integral of 3x over 6x squared minus 15 dx. And now I'm going to put in the u here. I'm not doing any calculus. I'm just replacing all of the 6x squareds minus 15s that I find in my integrand with u. So that's just the thing on the bottom. And now I'm in a situation where I have an indefinite integral that I want to integrate with respect to x. But I have a function that not only has a u in it, but also has an x in it. So we can't carry out this integration until all of the variables in the integrand are the same, and they also are variables that we're actually taking integration with respect to. So we can change these all back into x's, so the integrand all back into x's, or we can change everything back, or everything into u's. Of course, if we change everything into x's, we get our original problem, which was too difficult for us to solve. So let's try to figure out how we can turn this into everything to do with u's. So the next step in u substitution is to try to get rid of this dx, and we'll get rid of this dx by taking the derivative of u with respect to x, which in this case is just 12x. And now what we're going to do is we're going to quote-unquote solve for dx. Now of course this isn't a fraction, so it's not like you can go ahead and solve for dx. However, there are sophisticated reasons why in this case treating this as a fraction and solving for dx will actually give us the correct answer. So we're going to go ahead and do that. So if we multiply both sides by dx, we get du is equal to 12x dx. And then we're going to isolate for dx. So dx is equal to 1 over 12x. dx is equal to 1 over 12x du. So here I've just taken this equation and solved for dx, assuming that this is a fraction, which again, it is not, but it just happens to work for some sophisticated reasons. It happens to work to give us the right answer, so I'm going to use that to my advantage. So now wherever I see a dx, I can replace it by my new formula here. So I have 3x over u, and here's my new version of dx, so I can replace my dx with 1 over 12x du. And now I can see why I wanted my derivative of u to be a multiple of the 3x, because what I'm now able to do is actually cancel this x with the x that was still remaining, and I end up with the integral of 1 over 4u du. And of course this is just 1 over 4 times 1 over u, so that's just a constant times 1 over u, so I can take that constant 1 over 4 out and I have 1 over u du. Now I'm in a situation where I have an indefinite integral that is all in terms of the same variable, and it's the variable that I'm integrating with respect to. So I have formulas for this. The indefinite integral of 1 over u is the natural log of the absolute value of u plus a constant. And now what I want to do is I want to put everything back in terms of x. And so I look at what my u was. My u was 6x squared minus 15. And so I've got 1/4 natural log of 6 x squared minus 15 plus a constant. And now I'll simplify things by multiplying this 1/4 in against everything else. So I get 1/4 absolute ln of 6x squared minus 15 plus 1/4 c. And this 1/4 c is 1/4 times some arbitrary constant, some arbitrary number c. And of course, a number times some arbitrary other number will just give you an arbitrary number. So this becomes 1/4 ln 6x squared, let me write that again, 1/4 natural log of 6x squared minus 15 plus some arbitrary constant d. Of course, most textbooks leave this as c usually, but just for a little bit of clarity, I'm going to rename it d. This is just an arbitrary constant, and this is the final solution.